Okay, so today we are going to be covering probabilities of compound events. So a compound event is either the union or intersection of two events. If it's the union of A and B, that's this first picture up here, it could either be that A and B are completely separate or where they overlap, but either way, it's all of the probabilities together of A and B. If it's the intersection, then it's only the part where they overlap, okay, where it's both A and B. So the first one we're going to talk about is if it's a union or an OR type of compound event. So the formula you guys are going to be using is the probability of A or B happening is the probability of A plus the probability of B minus the probability of A and B. So what we're doing is this part right here, the probability of A and B represents that overlapping section in the center. Because if I don't subtract that out, then basically I've counted those twice because they're in A and they're in B. So I need to remove that overlap so I'm not counting those twice. If the events are disjoint or mutually exclusive, then the probability of them both happening is 0 because nothing overlaps, right? Make sense? Okay. All right, so let's take a look here at an example problem. A card is randomly selected from a standard deck of 52 cards. What's the probability that it's a 10 or a face card? All right, so in this case, the probability of getting a 10, how many 10s are in a deck of cards? 4. So I've got 4 out of 52 cards. That's the probability of getting a 10. The probability of getting a face card, how many face cards do I have? I have 12 out of 52. And is there going to be any overlap? Is there any way it could be a 10 and a face card? No. So this one is a disjoint set of events. There's no way it can be both of them together. It's either going to be a 10 or a face card. So the probability of it being a 10 or a face card is just going to be adding those together. 4 out of 52 plus 12 out of 52. And there's no overlap, so there's nothing I need to subtract. So 4 and 12 is 16, so 16 out of 52, and that can be reduced. So the probability that it'll be a 10 or a face card ends up being 4 out of 13. Okay, questions? All right, so now let's take a look at one where a card is randomly selected from a standard deck of 52 cards. What's the probability that it's a face card or a spade? So again, the probability that it's a face card, we have 12 out of 52. The probability that it's a spade, how many spades are in a deck of cards? 13 of them out of 52. But there's some overlap. There's the probability that it's a face card and a spade, because how many spades are face cards? 3. King of spades, queen of spades, jack of spades, right? So there's 3 out of that 52 that would be both a face card and a spade. So using the formula, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. The probability of A or B, the face or the spade, is going to be 12 over 52 plus 13 over 52 minus 3 over 52. And so 12 and 3 is 25, minus 3 is 22 over 52. And I can reduce that. So the probability that it's going to be a face card or a spade is going to be 11 out of 26 when I reduce the fraction. Okay. So this one was not a disjoint. This is one that had the overlap, so we had to make sure that we subtracted our overlap from our problem. All right, so now it's your turn to figure one out. A card is randomly selected from a standard deck of cards. What's the probability that it is an ace or an 8? Is there any overlap in this one? No, there isn't. It's either an ace or it's an 8. It can't be both. All right, so it looks like you guys were getting the right answer there. The probability that it's going to be an ace is 4 out of 52. The probability that it'll be an 8 is also 4 out of 52. And there is no overlap for this one because it can't be an ace and be an 8. So the probability that it's going to be an ace or an 8, you just add those together. And so we get 8 out of 52. And so then that reduces to 2 out of 13. So the probability that it would be an ace or an 8 is 2 out of 13. Okay, here's another one for you guys to try. A card is randomly selected from a standard deck of 52 cards. What's the probability that it is a 10 or a diamond? Is there overlap on this one?
Yes.
Yes, there is. Okay, so if I look at my diamonds, I've got an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. How many diamonds do I have? 13 of them. So the probability that it's going to be a diamond is 13 out of 52. Then I have my tens. I've got the 10 of hearts, the 10 of diamonds, the 10 of clubs, the 10 of spades. So what's the probability of getting a 10? 4 out of 52. But the problem is I've got my 10 of diamonds here and I've got my 10 of diamonds there. I don't want to count them twice. So the probability that it's both a diamond, oops, that's not a diamond. It's a diamond and a 10 is 1. So I need to subtract that out. So the probability that it's a 10 or a diamond is going to be 13 over 52 plus 4 over 52 minus 1 over 52. So 13 and 4 is 17, minus 1 is 16. And so if I go ahead and reduce that, it's 4 out of 13. Okay? Okay, so now we're going to look at compound events involving an intersection, the and part of it. So all I want to know is what's the probability of A and B. I'm still going to use the same formula, and then I'm just going to use algebra to solve backwards to find the probability of A and B. All right, so out of 200 students in the senior class, 113 students are either athletes or on the honor roll. There are 74 seniors who are athletes and 51 seniors that are on the honor roll. What's the probability that a randomly selected senior is both an athlete and on the honor roll? So first thing I'll do is write down my equation so I remember everything I need to find. So the probability of A or B is the probability of A plus the probability of B. Oops, that's supposed to be a P. Minus the probability of A and B. All right, so there are 113 that are athletes or on the honor roll. So the probability of A or B is that 113 out of the 200 total. Then it says there are 74 that are athletes. So the probability of A is 74 out of 200. And finally, there are 51 that are on the honor roll. So the probability of B is 51 out of 200. So now I'm just going to use algebra and solve backwards. So the probability of A or B, 113 over 200, has to equal the probability of A, 74 over 200, plus the probability of B, 51 over 200, minus the probability of A and B. So if I combine my 74 and 51, I get 125 over 200. And if I subtract 125 over 200, I get negative 12 over 200 equals negative probability of A and B. So of course I can just change the signs, and then I can reduce it. So the probability that they are an athlete and on honor roll is going to reduce down to 3 out of 50. Or if you want to make it a decimal, 0.06. So basically there's a 6% chance that they will be both an athlete and on honor roll. Questions? All right, so now we'll see what you guys can do. Out of 200 students in the senior class, 51 are on honor roll and 32 are in the band. There are 64 that are in band or on the honor roll. What's the probability that a randomly selected senior is both in band and on the honor roll? So use the formula. I'll rewrite it up here for you. Okay, so we have a total of 200. The number in honor roll were 51. The number in band were 32. The number that were in honor roll or band was 64. So when we set it up, we had 64 over 200 equals 51 over 200 plus 32 over 200 minus the probability of A and B. So if I combine my like terms, I get 83 over 200. Subtract that from both sides. I get negative 19 over 200 is equal to the negative probability of A and B. So you just divide both sides by -1. So the probability is 19 over 200, or if you want to make it a decimal, it would be 0.095. Questions? Alrighty.
You know if there's any way to find out who was in that?
All right, then, that's it for today.